Alright, so this week we are going to take a look at analyzing two ratios to determine if they are proportional to one another with a variety of strategies. Now, I'm going to be talking about two different strategies within this lesson, and it does not matter to me. So when you choose which strategy works for you, you really only need to focus on that particular strategy. Ms. Banks and I are not going to ask you to be solving it in one particular way, and that's the only way you can use. You can use either one of these two strategies. Before we get to the learning target, I want to review with you the targets that we have seen so far this year. Some of you have done really well with these learning targets in the past. Hopefully you remember them because we have word problems next week, setting up and solving proportional word problems. And then we will do a culminating review, and then it'll be the time for your unit exam. And with that unit exam will come the end of the 9 weeks. So we're going to take some time to review. You guys do not have clickers because you're not here with us at school. So we're going to ask you these questions. You're just going to pause the video, answer the question in Edpuzzle. So good luck to you. The first question, is the relationship shown in the table proportional? Remember, you need to check all of the table. Pause the video and answer the question. Okay, so as we hopefully remembered, that there's a couple of different ways that you could have solved this problem. You could have done cross products to see if they gave you the same answer. So 22,000 times 2 is 44,000. 44,000 times 1 is 44,000. That's a way that you could have solved it. Come over and do the same thing over here. I want to solve it in a different way. I want to say this is x and that's y. And I'm going to say k is equal to y over x. Now, you should have this familiarized. You should understand that k is the constant of proportionality. So we have 22,000 over 1, which is 22,000. Right? The next one is 44,000 divided by 2, which is 22,000. So we know that these two are equivalent to one another. The third one is 88,000 divided by 4. We know that that's equivalent. The last one is 110,000 divided by 5, which is 22,000. Now, since all of these ratios have the same constant, our unit rate, we would say that it is proportional. Number 2, is the relationship shown in the table proportional? Pause the video and answer the question. Alright, we have x and y. So the first thing, your constant is equal to y divided by x. Our first y value is 7 out of 2, and that is 3 5/10. The second y value is 17.5. 17 5/10 divided by 5, which is the x value, which is 3 1/2 as well. So we know that these two are equivalent to one another. Then we have 21 divided by 6, and that's going to be 3 1/2, or 3 5/10. 34 5/10 divided by 9. And this gives me 3.8. So the good thing about checking all of them is even though they throw this in at the end, we're still able to identify that this is not proportional because this 3 8/10 is not equivalent to 3 and 5/10. Number 3, is the relationship in the table proportional? Constant is equal to y divided by x. So the first y value is 5. The x is 1. 5 divided by 1 is 5. So you have a constant of 5. Second is 11 divided by 2. So 11 divided by 2 is going to be 5 and 5/10. So I automatically can stop here because we don't have a constant of proportionality for the table. Is the relationship shown in the table proportional? K is equal to y divided by x. Your first y value is 4. Then 1. 4 divided by 1 is 4. Second, 8 divided by 2 is 4. So we know that these two ratios have a constant of proportionality. The next one, 16 divided by 4. Now, when we're doing these, a lot of students only want to check the first two, and as we found out, we need to check all of them. 16 divided by 4 is 4, and 35 divided by 7. 35 divided by 7 is 5. Now, in looking at these, we are able to see that the first three have a constant, but the other one doesn't. So no, it's not proportionate. Alright, next one. K is equal to y over x. The first y value is -3 divided by 2. -3 divided by 2 is -1 and 5/10. The next y value is -10 divided by 4, and that is going to give you -2 and 5/10. First one we come to that are not proportionate, therefore does not show proportionality. Is the relationship shown in the graph proportional? Hopefully you said yes, and it is yes because it is a straight line that passes through the origin. Something that we want to also review here is if you have the point 0, 0, a lot of you know that is the origin, and on your assignment you wrote that it was the origin, but we wanted it in context of the problem. 0, the title of the x-axis is hours. 0 hours, 0 salary. So if you work 0 hours, you will make $0. Okay? For this one, 1:15. For 1 hour, because this is the x value, this is the y. For 1 hour, you're going to make $15. Okay? That's in context of the problem. This one. Alright. Hopefully you said no. It's no because it does not pass through the origin. Although it's straight, remember it's got to do both. It's got to pass through the origin and be a straight line. For this one, hopefully you say yes, because it is a straight line that passes through the origin. For this one, hopefully you say yes or no. Which one do you think? Hopefully you said no, because it does not pass through the origin. It is a straight line, but it doesn't pass through the origin. Number 10, yes or no? Hopefully you said yes, because it is a straight line that passes through the origin. Alright, now let's talk about how to determine if two ratios are equivalent to one another. Cross out all of the ratios that are not equivalent. So write these down, identify which ones are and are not equivalent. Think of the butterfly method that we did. Alright, so you could have done this a couple of different ways. Scale factor was a way that we talked about earlier. You could have said, what times 6 gives me 18? Well, 6 times 3 gives me 18. And then come to the denominator, multiply it by the same scale factor. 11 times 3, is that 33? Yes, it is. So that means that this is proportionate. They are equivalent. You also could have done the butterfly method, where you did 19 times 5. Well, 19 times 5 is going to give you 95. And you do 17 times 7. And 17 times 7 is 119. 119 is not equal to 95. Therefore, this is not proportionate. The next one. What times 7 gives me 21? Well, multiply by 3 again. Come to the denominator, multiply it by 3. So since 7 times 3 is 21, 11 times 3 is that 33. Yes, it is. So we know that this is proportionate. Butterfly method. What if I did 96 times 5? 96 times 5 is 480. And I'm going to do 60 times 8. And 60 times 8 is 480. And since the two products are actually equal to one another, we would say that this is proportionate. The next one, 4 and 8. What do I need to do to 4 to get to 8? Well, I multiply it by 2. I come down here, multiply this by 2. Is 9 times 2 16? No. 9 times 2 is 18. Since this is not a true statement, we would say that this is not proportional. 2 times 8. No, I'm sorry. What times 2 gives me 8? 2 times 4 gives me 8. Come to your denominator. Multiply it by 4. Is 3 times 4 9? No, it's not. So we know that this is not proportional. Let's do the butterfly method real quick. 5 times 12. 5 times 12 is 60. 4 times 15. 4 times 15 is 60. Since these are equivalent, then yes, they do form a proportion. Last one. So sometimes scale factor, if you look at this, what times 13 gives you 25? Well, there's not an even nice number that we can multiply 13 to get to 25. So the butterfly method works out better. So 72 times 13 is 936. And 25 times 24 is 600. These are not equal to one another. Again, remember this is the symbol for not equal. So that means this is not proportionate. So there's two things that you had to remember on this one, the butterfly method and scale factor. And both of those are going to be important here in just a moment when we talk about our learning target. So remember our learning target about solving proportions with two different strategies. And so here we have a proportion. We have 2/5 is equal to 8 over x. And our goal is to identify what the value of x is. Okay? There are two different ways to do this, and I'm going to walk you through two. And I need you to really pick one as to which one you really like and which one you understand, and then do that one from here on out. The first one that I'm going to talk to you about is scale factor. Scale factor works most of the time. It doesn't all the time, but it works a lot. So the first thing I want to do is look at the two numbers that I have. So I'm going to I have the 2 here, and I'm going to say, well, what number do I multiply the 2 by to get to 8? That's 4. So I have times 4. Then I'm going to come to the denominator. I'm going to do the same thing. I'm going to multiply it by 4. Okay? And then I'm going to say, well, 5 times 4 is 20. Therefore, x is equal to 20. The goal of this, guys, is to identify what number I need to place in for the variable to make these equal. Okay? That's known as scale factor. It works most of the time. The next one, or the next way, is the butterfly method. So I have 2/5 is equal to 8 over x. So with the butterfly method, 5 times 8, 5 times 8 is 40. 2 times x is 2x. Okay? I'm going to bring down the equal sign. Now, this is a one-step equation, which you should remember from 6th grade. You should be able to say, well, the 2 is trying to multiply. My goal is to get x by itself. So I do the opposite of what it's trying to do. I divide both sides by 2. 2 divided by 2 is 1. The way we write 1x is simply x equals 40 divided by 2 is 20. Again, we're going to get the same way, or the same answer, depending on which way you choose. I do think that this is more complex for students to understand, but this one works every single time. This one works most of the time. It doesn't matter to me or Miss Banks which one you choose. Let's do another one together. So here we have 4 over 9 is equal to x over 36. So the first thing that I notice is the 9 and the 36. So what do I have to do to the 9 to get to 36? I'm going to multiply by 4. Okay? And since I multiplied this by 4, I got to come up here and do the same thing. And I'm asking myself, 4 times 4, well, the value of this has to be 16. So x is equal to 16. Because remember, the whole purpose of this is to replace the value of your variable with a number that would make the two ratios equivalent or equal to one another. Let's do the next one. So the next way is the butterfly way. So we have the butterfly method, which is 4 over 9 is equal to x over 36. So we're going to multiply diagonally. The first thing I have is 9 times x, and that's going to be 9x. And the next thing that I have is 36 times 4, and that's going to be 144. Bring down your equal sign. Now remember, your goal is to get the variable by itself. So the 9 is trying to multiply. You're going to divide both sides by 9. 9 divided by 9 is 1, and the way we show 1x is x. So we say these cancel almost. Leaves you with an x is equal to, and 144 divided by 9 is 16. Ended up at the same place. Two completely different strategies. This works every single time. This one works most of the time. Alright. This one, I want you to try it on your own. There's not going to be an Ed puzzle question, but I want you to pause it, and I want you to see if you can solve it. Okay. Now that you've paused the video, hopefully we get the same answer. So the first thing that I notice is the 7 and 35. So what do you have to do to 7 to get 35? And hopefully you said multiply by 5. Okay? Come down, do it to the denominator. 2 times 5 is 10, therefore x has to be 10. Remember, your goal is to identify the number that needs to be put in place of x so that the two ratios are equivalent or equal to one another. The next thing, cross products. If 7 halves is equal to 35 over x. So with cross products, 2 times 35, 2 times 35 is 70, 7 times x, 7x. Bring down your equal sign. Now, what you need to do is identify that you need to get the x by itself. So we need to get rid of the 7. The 7 is trying to multiply your variable. So the opposite or inverse operation is to divide. And you got to do that to both sides to keep them equal. 7 divided by 7 is 1. To show 1x, we simply write x. 7d divided by 7 is 10. Okay? Now, what I want you to start thinking about is, if you like this method, that's fine. I have no problem with it. But remember, it doesn't work every time. So understand that you could be asked to do this one if your scale factor doesn't necessarily work out. Alright, here we have another one. Again, pause the video. See if you get the same thing that I do. There will not be an Ed puzzle question over this. Alright, next, I see that the 12 and the 60 are both given to me. And I'm thinking, okay, what times 12 gives me 60, and that's times 5. I come up here, multiply the 4 by 5, x is equal to 20. So I know that 20 over 60 is equal to 4 over 12. Again, that's scale factor. X over 60 is equal to 4 over 12. So I have 60 times 4, which is 240. X times 12, which is 12x. Don't forget the equal sign. Now remember, you want to get x by itself. The 12 is trying to multiply the x. So you need to do the opposite to cancel it. So you divide both sides by 12. 12 divided by 12 is 1. and we don't write 1x. Okay, you won't see it written this way. It's simply written x is equal to, that would be 20. Okay, got the same answer. Doesn't matter which way you chose to answer it. All right. Yeah. All right, so we're going to do one more, and then we're going to start doing some puzzle questions. So for this one, 17 and 51. I can't think of anything that easily would multiply, okay? Now, I know that I can multiply 17 times 3 to give me 51, but let's say I don't know that. I need to be able to use my butterfly method. So 51 times x is 51x. 9 times 17 is 153. Remember, your goal is to get x by itself, so you want to divide both sides by 51. 51 divided by 51 is simply x equals, and then 153 divided by 51 is going to simply be 3. Okay. Now with scale factor, you could have said 17 times 3 gives me 51. So what number times 3 gives me 9? And so that number would have to be 3. Okay? Good. All right. So now, got some questions. Pause the video and answer the question. All right, so for this one, you could have done scale factor if you wanted. So 3 times 7 gives you 21. So what number times 7 gives you 28? And that value is 4. If you did cross products, you would have did 21 times x, 3 times 28. For this one, use cross products to solve. You can use scale factor if you want. Pause the video, answer the question. So for this one, I'm going to rewrite it over here. I've got, copy this down, it should be 60. 15 times x is 15x. 2 times 60 is going to be 120. Bring down the equal sign. Remember that your goal is to get x by itself, so I'm going to divide both sides by 15. The 15's cancel. X is equal to 8. Last one. So for this one, I look at the 3 and the 7, and I think, okay, I can't think of anything to make this 3 into a 7. So I'm going to have to use the butterfly method. So I have x times 3, which is 3x. I've got 21 times 7, and that's 147. I'm going to divide both sides by 3. 3 divided by 3 is 1. We write 1x by writing x. And 147 divided by 3 is 49. C. Okay, now, please make sure that you can use scale factor or you can use the butterfly method to determine the values of variables. Remember that the butterfly method works every single time and the scale factor works most of the time. Guys, we're finishing up this unit. This is a fairly easy learning target. I do hope that you are understanding this well. If you are not, then you need to reach out to Ms. Banks or myself so that we can help you. You can also attend our Google Meets on Monday, Tuesday, Thursday, Friday, 9 until 10. Guys, if there's anything we can do, don't hesitate to ask. Other than that, have a great week, and I'll see you in the Google Meet.